Okay, well, my apologies that the last couple of videos have been getting kind of long, so I'm going to try to make this one really short. Tonight, we're going to talk about Lesson 3.4, which is a lesson on formulas. All right, so let's start out with what is a formula. All a formula is it's an equation that shows the relationship between some different variables. Now, your book actually says between two variables. It actually says between two different quantities that are represented by variables. The reality is that actually you can have more than two variables. In fact, the very first example they use in the book is D equals RT, which is a famous formula. Yep, sorry about that. All right, my video just did something weird. Like I said, the main example, the very first example in the book, you'll find is D equals RT. And this is a very classic equation. You use it a lot in science, especially in 7th grade science with Mr. Johnson next year. It stands for distance is equal to rate times time. This is basically the equation you use when you're driving somewhere. So if you're driving somewhere and you're going 50 miles an hour and you go for 3 hours, you're going to drive 150 miles. So what you can do in that example is you take your rate, which is 50 miles an hour, and you multiply. By the way, the RT is R times T, a little dot there. You don't have to write it, but it's automatically implied to be two different letters, and since there's nothing between them, it's implied that you multiply. And the time was 3 hours, and so the distance that we traveled would equal 150, and you always label your answer miles. Okay. On the other hand, suppose I knew that I went 200 miles, and I was driving 40 miles an hour, and I wanted to know how long it took. Well, now we'd solve this equation, so we'd divide both sides by 40, and we can find out that the time is equal to, if you divide this, 20 divided by 4 is 5, so it'd be 5 hours. Okay, and so this is a very classic formula. Okay, D equals RT. A less classic but very fun formula is this one. Okay, and what this approximates, this is supposed to be the temperature in degrees Fahrenheit. And if you go out some night on a summer evening and there's a lot of crickets making noises, and you find one cricket and you sit and you listen to him and you count how many times he chirps in a minute, that is what N is. Okay, and so you just set a little stopwatch and count how many times the cricket chirps, divide that number by 4, and add 37 to it. And it's a surprisingly accurate predictor of the temperature in Fahrenheit. So quick example, so let's say you do this. Let's say that the cricket chirps 100 times in a minute. Okay, so what you would do with this formula is you put 100 in for N, you divide that by 4, and you add 37. So let's do our work. Notice I'm working down. 100 divided by 4 is 25. Plus 37 is equal to 62 degrees Fahrenheit. Okay, and what it basically, the reason this works is the warmer it is, the more active crickets get, and the more they chirp. The colder it gets, the less they chirp. And so by counting the number of chirps, you can pretty accurately, surprisingly so, figure out the temperature. Again, the crickets are not so important as the formula. So F, the temperature in Fahrenheit, is equal to N divided by 4 plus 37. Again, that's an example of a formula. All right, geometry is full of formulas. You know several of these. If you want to do the area of a rectangle, you multiply its length times its width. Okay, if you want to do the perimeter of a rectangle, you double the sum of the length and the width. If you think about a rectangle, okay, and this is the width and this is the length, what you basically do is you add up one corner, so you'd add up around this side here, so you'd add this and this, that's 1/2 of the perimeter, and then double it, and you get this and this, and that would be a total of 2LW. Sometimes people will write that out where they've distributed, and so you get 2L plus 2W, which is a little more work, but it does the same thing. Area equals pi times the radius squared is the area of a circle. Okay, the circumference of a circle is pi times the diameter. The area of a square. Okay, we'll draw a little picture of the circle. Okay, the area of a square is S times S, or S squared. The perimeter of a square, add up all the S's, there's 4 of them, so it'd be 4 times S. Okay, so there's just all kinds of formulas in geometry, and actually towards the latter part of the year, we're going to spend a couple chapters doing geometry, and we will actually practice several of these formulas. Okay, and we'll practice some of those in our book tomorrow. The one that they used in the examples in your book was the perimeter of a rectangle. So again, what we're interested in here is a formula where the perimeter is equal to 2 times the sum of the length and the width. Okay, and so most of these formulas, you notice, a lot of times have more than 2 variables. Okay, so basically, to work with a formula, you put numbers in for the variables, and you just do the math that we've been doing the last couple days in class. I'm not going to belabor this point. That really is all there is to formulas. And since I've been kind of pounding you with these long videos the last couple nights, let's keep this one nice and short. So we'll practice using formulas tomorrow in class. That is the 3-4 lesson. Also make sure, if you're listening to this, if you haven't watched in its entirety the 3-3 video, if you didn't watch the very end or something like that, please go back and review that. And if you haven't finished your 3-3 classwork, we'll wrap that up as well. Okay, so that's it. I'm going to sign off for tonight. I will see you all in class. Take care, everybody. Thanks for watching.